So now let's look at our special cases. Just like when we solved by substitution, when we solved by elimination, we also have special cases. So let's look at number 3 and 4. First, let's look at number 3. Check to make sure that all the terms are lined up above each other. Our x terms are lined up above each other, our y terms are lined up above each other, and our constant terms are lined up. So that means we are set up to solve by elimination. The next thing we need to check for is, do we have opposite coefficients? The x terms are opposite coefficients because 2x and negative 2x are opposites, and they will cancel out. So now that we know that we have opposites, and now that we know every term is lined up where it should be, we can go ahead and add the two equations together and solve by elimination. 2x plus negative 2x will cancel out. Well, actually, negative 3y plus a positive 3y will also cancel out because the y's are also opposite coefficients. So we get 0 plus 0, then we bring down our equals, and then the 12 plus positive 8 equals 20. Now simplify. 0 plus 0 is 0, and bring down your equals 20. So our answer is that 0 is equal to 20, and both our x and our y variables have canceled out. When your variables cancel out, that is your clue that this is a special case. You have a special solution. So we need to see, is our statement true or is it false? Will 0 ever be equal to 20? No. So it is a false statement, and the answer here is no solution. And when our answer is no solution, we have lines that are parallel because they will never intersect, so they will never have a solution. Now let's look at number 4 in our other special case. Again, check to make sure that all your terms are lined up. Our x's are lined up, the y's are lined up, and the constants are lined up, so we're ready to solve by elimination. Now check to make sure that you have opposite coefficients. And in this case, our x and our y terms are opposite coefficients. So let's go ahead and add these together. And positive 2x plus negative 2x is 0. Negative 3y plus 3y is 0. And 12 plus a negative 12 is 0. So, in fact, all of our terms canceled out here. But go ahead and simplify. 0 plus 0 is 0. Bring down the other side is 0. So, again, our variables have canceled out so that we know that this is a special case. This is a special answer. Now we have to check to see if our statement is true or is it false. Is 0 equal to 0? Yes. So it is a true statement. Therefore, our answer is infinitely many solutions. In other words, INS. And our lines here, if we looked at them on a graph, there may be two equations, but we would only see one line because those lines are the same. Now let's practice some more. Look at number 5. What do you notice that's different about number 5 from all the other systems that we have solved so far? Hopefully you noticed that our terms are not lined up. We have x's above y's and y's above constants, and our equal signs are not lined up. So that means that we have to move things around in order for us to line things up and solve by elimination. So what do you think we should move first? In which equation should we move it? In our first equation, we have the x and the y term on one side of the equal sign, and then we have our constant on the other. In the second term, or in the second equation, we don't have that, so we need to move our x and our y to the same side of the equal sign and have our constant on the opposite side. So let's move the 4x from the right side of the equal sign to the left side. We cannot combine an x and a y term, so we just list them out. So now we have 4x plus 3y equals 14 for our first equation, and negative 4x plus 2y equals 6 for our second. So let's go ahead and rewrite those. Now look and see, do all of our terms line up? All of our x terms are lined up, our y terms are lined up, and our constant terms are lined up. Now check to see if you have opposite coefficients. Hopefully you notice that the x terms are opposite coefficients. So now let's add the two equations together and solve by elimination. Alright, so 4x plus negative 4x is going to cancel out and equal 0. Positive 3y plus positive 2y is a positive 5y. Bring down your equal sign, and 14 plus a positive 6 is a positive 20. So now, simplify and get y by itself. Well, 0 is not going to change the value of our equation, so we can just mark that out. And now we need to get y by itself by dividing by 5 on both sides. So y equals a positive 4. Now remember, what does the solution to a system look like? It's always going to be a point. It's going to be an ordered pair, unless it's one of your special cases. So go ahead and write out your ordered pair. And where are we going to put 4? Y equals 4. It's going to be the y value of your ordered pair. Now how do we find the missing x value? Hopefully you remembered that we're going to take the y value and take it and plug it back into either of our two equations from the very beginning. I'm still on number 5, but I'm going to use this space for number 6 to finish answering number 5. So we'll come back to number 6 in a minute. But we're going to take the y value and plug it into either of these equations. And again, it does not matter which one. I'm going to plug into the second one because to me that looks easier to solve. Okay, so again, I'm taking the y value and replacing the y value in one of our equations. So it's going to become 2 times 4 equals 6 plus 4x. So now simplify and solve. 2 times 4 is 8. Bring down the right side. Now solve for x. Subtract 6 on both sides. And we get 2 equals 4x. Divide by 2 on both sides. Or I'm sorry, divide by 4 on both sides. The 4's cancel out. And 2 divided by 4 will reduce to 1/2. So our x is equal to 1/2. And we take that and put it into our point. So your solution is 1/2 4. That is your final answer. Now I want you to try number 6 and number 7 and have those ready to go when you come to class, and I might call on you to tell me what you got.